And the person that complained that they don't watch stove videos unless it's burning can finally rejoice. Hey guys, Stove Talk with Matt. At the end, for the real stove nerds, I'll have an in-depth discussion on the continual quest to understand what makes smoke, what doesn't make smoke, and everything learned in this test. Adding this in to the front, guys, at the end, because it's so important. It's like life and death. Carbon monoxide. If you decide to create a no-smoke stove, if you choke it down, whether you use a rocket stove type port or this sort of funnel, have everything squeezed through a small space. You have to get it right so the gases in this carbon monoxide doesn't leak out the wrong direction. We talk about it in the back. Be very, very careful with this. I know I have a nozzle in the house in the form of a, what do you call it? It's a bartending tool. You shake up cocktails and shit. Standard 5 brick, full brick opening for your chimney. Okay, she went smoke-free after about 4 minutes. That's not so bad. Not even 5 minutes in. I'm using that nozzle to force everything through that real small space. If you let it go up a huge chimney, it'll smoke. That chimney's too big. That lets so much, the air comes so quickly from the front and up that chimney. If you were just making a stove out of fire brick, that you would smoke like crazy until it got super hot. It would take 10 or 15, 20 minutes to go low smoke because all the cool air just rushes up so fast and the air never gets a chance to get hot. So the idea is to push everything through a small space like a catalyst, but obviously a lot different than a catalyst. So what I did is made this, and there's your nozzle rocket, and then I placed this over top of this, and the results were really, really good. I loaded some new wood. Smoke's coming from the bottom as it typically does when you have no mortar. I loaded the new wood just about 5 minutes ago. It smoked for 4 or 5 minutes because I loaded pretty big pieces, but then it calms down. I'm going to do a few more tests, but you just, and also on the cheap, you just get an ash clean out door, which fits perfectly. An 8-inch ash clean out door fits perfectly on a stove that's only 2 fire bricks wide. You get a picture of what's going on in there. Flame's almost making it to the top. Not quite. Almost. Put the door on. This is kind of simulate, how it would be working as a real stove. You wouldn't even let that much air in. If you're using this as a real stove, it's still way too much air. See that smoke coming out the top there? Just because I don't have any mortar. I don't like how some smoke's coming forward. You create a little smoke shelf in there. So this can't happen, but that's easy to do if you're making this on your own. As the insulated pipe heats up, it's going to draw harder and harder. Every once in a while there's a little bit of a flame that shoots out. Let's see if we can see. Yeah, it's coming up a little higher now. See it level. Yeah, there it comes out a little bit. Little flame. Yep. Probably could see it if it was darker. And a few minutes later, I mean, if flame's shooting all the way up that insulated pipe, it's certainly going to eat up all the smoke. I mean, it's just so hot in the funnel and in the insulated pipe that the smoke is getting eaten up. Now, if you just had a regular single wall stovepipe, would you still get no smoke? Is all the smoke being eaten up by the funnel or by the insulated pipe? Both, I would say. I don't know. I don't think I'm going to do any more tests on this design. It's pretty easy. You can make an insulated pipe in just a few hours with some basic materials. It's easy to make. The first 5 or 6 feet of any stove really should be an insulated pipe. So it's easy to do this. And then just after, if I was doing this in my house, after this insulated pipe, then it just runs 10 more feet of regular single wall or regular, double wall if your code requires that to get through the attic. But this insulated pipe is packed with mineral wool. I thought it was packed with perlite, but it's mineral wool, so it gets super hot. If I loaded this up to the with wood to the very top, I mean, flames would shoot up 3-4 feet out of here. It's not that much wood. 4 or 5 minutes later, still nothing. No more flames at the top. The fuel's dying off. Well, there's something that just came out. Let's see what it looks like. Maybe 15 minutes later, and there's no smoke here still, but it is smoking like crazy from the bottom, and we need to talk about that. That tells you a lot why that's happening, and that either the insulated pipe or the funnel is taking care of the smoke and using this fuel. It's squeezing through, it's squeezing under that plate, squeezing through, there's no mortar. And the outside 1.5 inches of these bricks is relatively cold, and that creates smoke. We can learn a lot from this. We'll talk about it. Let's see how we're doing in the firebox. Nope, a little bit left. Door's gone, a lot more air. Didn't change much. I'll show you. This fuel's got to be mostly gone. I mean, yeah. As soon as we lost the flame. Interesting. Big time smoke. Okay, let me put it out. Don't try this at home with red brick. They'll all crack. Fire brick has a lot of sand in it. Silica, no problem. Starting the back-end discussion, which will get very detailed as we go on. One of the main takeaways from this experiment, guys, is if you put just the 6-inch stovepipe on the back of a stove like this, without the nozzle, would it be no smoke? In my opinion, it would not be no smoke. It would smoke quite a bit, even with the insulated stovepipe. If you just put regular single-wall stovepipe, it would smoke quite a bit without the nozzle. And again, the air is moving so quickly through the stove, and cool air is getting up into the chimney, and that's just a recipe for smoke. You need a superheated zone, whether it be that be part of the firebox or right on the other side of a rocket stove port. You need a superheated zone that pushes up over 1,000 degrees for all the smoke to be eaten up. There's no secondary air or anything in a stove like this. This stove would not be great this would not do well with secondary air. So I do think just the 6-inch insulated stovepipe on the back without that little nozzle to squeeze everything through a superheated zone, I think it would smoke. I'm not sure I'm going to try it with an experiment, and where I'm not sure is maybe the insulated stovepipe, as it gets hot, as its insulated pipe, might create enough high temperatures where it would eat up all the smoke. But I just in terms of the stoves that I make, it's usually the stacking of fire brick, and I can tell you 100% of the time when it's the stacking of fire brick, but that's different because fire brick stays cold for a long time. Whenever I've made the chimney too large with my fire brick stoves, smokes like crazy. There's no superheated zone. Air moves through too quickly. It's like air conditioning, and it smokes. Okay, the next discussion. Why did it smoke at the end when it was just down to coals? And in my opinion, the superheated zone was gone because all the flame was gone. I did remove that mineral wool door, but it didn't make any difference. It smoked the same because too much, whether the mineral wool door was there or not, too much air was coming in too quickly. That's air conditioning. Air conditioning over coals, and in a space, the space gets cold very, very quickly. It only burned once, so that the fire bricks are not superheated. It simply creates air conditioning, and you can see the tremendous smoke that's coming from the bottom of the stove as well. The flames being concentrated is that superheated zone that burns up the smoke. It's almost like so much air was coming in. It was cooling everything down. Everything cooled down immediately, and it wanted to get started again. You know how it smolders or it smokes before it really flames up when you're starting a fire. Now, to combat this, someone's like, well, I want to build this. I don't want a bunch of smoke at the end of every fire session. To combat this, it's too much air coming in. It just cooled everything down very, very quickly, creates smoke. Now, I would just simply you have it in your more permanent door situation. You'd have an air slider, and towards the end of the burn, you would really start to choke the air down quite a bit. Remember, an iron wood stove only has 2 little air holes the size of dimes or the size of nickels. That's all an iron wood stove has. Even maximum air, that's all it lets in. So this stove does need a little bit more force to squeeze everything through a small space. But when it's going towards coals, you would really move your slider across or whatever you decided to do for air, and that also keeps the heat inside the firebox. I don't think it would smoke much. It is a little surprising though, because like my ironwood stove, when it goes to coals, it doesn't smoke outside. But everything is so, concentrated. The heat is concentrated in a much smaller firebox. And this is only one burn, so the fire bricks are still relatively cold. And, there's no more superheated zone. And even the insulated chimney pipe cools down quickly. So just cool air across coals is creating that smoke, in my opinion, where if you had this in your house, you're burning it hours and hours and hours, everything was superheated, you could slide that air slot down to very, very low. I think it would be much, much better. But the amount of smoke at the end, I don't know, it was a little surprising because I don't get that in all my tests on different configurations of stoves. I've had rocket stoves do similar things. No smoke, of course, but at the end, they've smoked certain rocket stove configurations. This phenomena is fun to talk about again where the bottom will smoke because it's finding its way out through the seams. Again, just a test, there's no mortar. But the top, if you pan the camera up to the top of the insulated pipe, there'd be no smoke whatsoever for 30 minutes. So why is smoke coming out the bottom? And it's interesting dynamic. We could learn a lot that I like to talk about. In this particular stove, there is the chimney goes up, one full brick opening goes up 3 levels, one full brick opening before it's squeezed through the nozzle. One full brick opening chimney is made by surrounding it with 5 fire bricks. So everything hits this box, which is squeezing up into this box, and then it has to squeeze again into a much smaller space, the nozzle. So remember, like in All in the Family, Archie and Mike going through the same door, the Three Stooges going through the same door at once, they get stuck. That's what's happening at the nozzle. So some smoke is actually almost pushed out the cracks and seams of this test. There's no mortar. And what happens is, I've said this before and some of you have disagreed, it might be no smoke, but when it's pushed through the seam and it runs by a kind of a ice cold brick, the outside of these fire bricks are not hot at all, no smoke can actually go to smoke. Now, people have disagreed with me on this. Matt, once it goes no smoke, it's no smoke. I've seen it too many times. It will, if it cools down, this is the principle of why I got smoke at the end. When it cools down, it will go back to smoke. I've just seen it too many times. I'm convinced of this. Okay, the back-end discussion will just be on a few photos, maybe just 3 or 4 photos. It's only for the real hardcore stove people, or the people that want to build this, those demanding to see fire and entertainment. This is not going to be for you. What's hard, the hard to do with a stove like this is to create no smoke. Because when you have a low ceiling firebox, a long low ceiling firebox, I like these stoves that are just 2 fire bricks wide, very thin. That concentrates heat, creates a tremendous amount of heat in a long and thin firebox, and that burns up the smoke. If you want a no smoke stove, you either have to have a very high firebox, a good 10 bricks higher than this, and let the flames lap up high. That flames lapping up burns up the smoke. But if you have a long and thin firebox, you need to do some things like what I did here with the nozzle to create a no smoke stove. A long, thin firebox with a low ceiling, especially when you have the flames lapping up into the relatively ice cold brick relative to the flame, that creates a lot of smoke. A high firebox where flames lap up in the air burns up the smoke. The flames hit the low ceiling firebox, and these flames are cooled down like 100 degrees and 200 degrees immediately. So one of the things I have, pet peeves I have with all the Russian videos I watch, these giant double bell masonry heaters, they never show you, very, very rarely show you the pipe and the smoke outside. And maybe it's just a thing in Russia. It's just assumed that you're going to smoke out the town. I don't, I would think they would be relatively low smoke, but few of these masonry heaters that I see, I bet for a long time they smoke pretty heavily until like everything gets hot. They almost never show you the chimney or the pipe. So for this stove, thin firebox, very low ceiling, long. If I was going to build this in my house, I probably would make it another fire brick long. There's no problem in going longer. You can throw huge pieces in. This, I think you can put in up to 27-inch logs, but if you go another fire brick, which is 9 inches, up to 35-inch logs, why not go longer? I think it actually creates more pull of the draft, and the air, the primary air will come in even more forcefully if it's thin and low ceiling. Okay, why not even go longer? Okay, so you have 2 choices if you don't want to smoke out your neighbors. One is the classic rocket stove port, the thin port at the back of it. Everything, all the heat is concentrated going through that thin little rectangle in the back. and all the flame comes together, which burns up the smoke. And then when it hits the back riser, there's turbulence, and that, of course, burnt with a rocket stove is very effective in burning up the smoke. That was a possibility here. You could simply have a long, just simply put a port in the back, and use the rocket stove principles to create no smoke. I just wanted to experiment with something different, and it worked. So the other way to do it, and this is similar to what we did 2 or 3 videos back with that stove, where the ambiance of having the flame lap up on the back, you can see through the little glass window. That I used a metal plate to squeeze the flame through a very small space, and that eats up smoke as well. Here, the concept was to squeeze the flame through the bartender's cocktail shaker, and it held up very well. I don't know, I know someone's saying, "Oh, it's not going to hold up over time." We'll maybe talk about it at the end. You could use castable refractory, not refractory mortar, castable refractory to surround the bartender shaker. Anyway, the idea is let's just stick to the basic concepts and things that we've learned. All the flame, in my opinion, this is what happened. All the flame shot up through a very, very small space, and it was most of the smoke was burned up because all that flame converges, and the smoke has to be then pushing right up against the flame, and poof, it burns up all the smoke. It took about 3 or 4 minutes for it to go smoke free. Then I have the insulated pipe on top of the nozzle, and I think that as the insulated pipe again gets super hot because it's insulated with mineral wool, I think there's probably another 10 inches or so of the insulated pipe that helps burn up the smoke because it reaches super high temperatures. Somebody may ask, well, what if you just forget the nozzle? What if you put just the insulated pipe over the back of a stove like this? I think it would smoke. I don't know if I'm going to do that test, guys. This is a 6-inch pipe, and that's a wide space. One of the things that we're learning against the old dogma about making stoves and the horrible designs of American fireplaces and American chimneys, I mean, just horrible designs. We're learning that the chimneys don't have to be very big. The risers of a rocket stove don't have to be very big, but you could apply this to almost everything. Even those, some people have like an iron stove, and they'll put, like, some iron stoves have an 8-inch pipe on the back. I mean, there's just no need almost ever for an 8-inch pipe, unless you put like an 8-inch pipe over a large open fireplace. And even then, open fireplace in somebody's old house, the chimney is like 3 times as wide, a brick chimney, 3 times as wide as an 8-inch pipe. All it does is allow for cold air and smoke. It's horrible. So we're learning in general. Now, this is the limit, guys. For this type of stove, if I were to load in, I would like to have tested. I loaded in, oak pieces that were split pretty small. Pretty small. If I were to load in, if I made this Firebox 1 or 2 more bricks high, it still would be relatively low, thin and long, so you'd have that draft pull from the front. If I put in 4 or 5, or let's say 3 or 4 pieces of oak, bigger pieces of oak, would it have backed up? That's the key. If you're going to build something like this, you have to be very careful. Is that small nozzle just too small? Okay, standard stovepipe is a 6-inch opening. The start, or the wider part of the shaker nozzle, was 3.5. It tapers down probably to 3.25, or close to 3. Again, guys, you have to err on the side of being safe and not poisoning yourself in carbon monoxide. This is a little too tight. If I was especially if you were going to make a bigger firebox. If you're using a real thin, low ceiling firebox, small sticks, this should be fine. But if I was building this, especially if I was putting it in the home, if it were me, I would use to incorporate these principles, I would get a 4-inch pipe that's not tapered. Like you could get, it's like even a piece of galvanized dryer vent. and I would use a 4-inch pipe going up, say, the first 10 inches, and then I would, someone say, well, that's not going to last. Well, I think if you put the 6-inch pipe over top of the 4-inch pipe going up 10 inches, and then you filled the space with castable refractory, that should work. Not regular castable refractory. I'm not an expert on working with that. Do you use little pieces of nails or rebar to hold it? I don't know, but you're going to be putting that 4-inch pipe going up 10 inches inside a 6-inch stovepipe. So if the galvanized pipe initially gets all whatever, if it gets holes or gets eaten away, you should have that castable refractory should still be there. And the idea is, again, you're then funneling. There's no reason for this to nozzle it down. I mean, I don't see any real point in that. In my original test that I did not film, when I pulled the big piece of insulated stovepipe off the nozzle, I thought the flames would be shooting up the nozzle 2 or 3 feet, because I could see flame at the top of my insulated stovepipe. But as soon as it was the insulated stovepipe was actually the thing pulling the flames up hard through the nozzle. There was no pull when I simply pulled it right. I just simply took it off in the middle of the burn, pulled the insulated stovepipe up and off. So all I had was what you're looking at. The only chimney I had was the bartender's shaker nozzle, and that little flames came out the top. There was no huge shooting of flame. There's nothing pulling. It's not big enough to pull like a chimney. And then eventually it started to smoke and sputter. There's just no draft with you need a chimney. And that the 2-foot piece of insulated stovepipe, it acts almost like a 6-foot piece of non-insulated stovepipe in its pull. It just pulls. A long insulated chimney pulls and sucks and is 80% of your entire system. So that's another thing to talk about here. If your chimney, whatever you put on top of your well, let me just, the main point is, if you had your 4-inch pipe and then put castable refractory around that, 4-inch going up 10 inches. I think that's a small enough space where you're gonna, all the flame will be intermixing with the smoke through a small space, and I think you'd get a smoke-free stove. I think 4 inches from not nozzle down is a small enough space to eat up the smoke, but large enough where if you decided to make your firebox a little bit bigger, you definitely stay low ceiling, long and thin for this type of stove. I think it would be very safe. I don't think there'd be any chance. I had nothing coming out the front. So that's what I would recommend, 4-inch galvanized with castable refractory around it going up about 10 inches. Then I would make sure your next 2 or 3 feet of stovepipe is insulated, is very warm. Again, if you're going to make the fire and smoke go through a very small area, and get 4 inches is pretty conservative. That's not real small. And maybe things would still move a little too fast, and you'd get a little bit of smoke. But if you remember, one of the most important thing in this presentation, in this video, is if you ask flame and smoke to go through a small space, you better be pulling hard on the other end with a warm insulated chimney. For example, you're asking the smoke to go through a small space, but then you're just going to put it right outside, right through the wall, and 8 or 9 feet of your chimney going up above the roof is outside, getting ice cold, especially when your flame inside goes to coals or very low. It's going to stop pulling. And if you're asking the flame to go through a small space, not a good idea. It could back up into your house, and that is so. At minimum, if you do anything like this and you nozzle it down, you have to have the pull on the other side, and a chimney that goes up through the middle of the house stays warm is always best. At the very minimum, make 2, 3, 4, 5, or 6 feet of double wall insulated, like if you can make what like I made, mineral wool insulated, it'll pull like crazy. And then you can do whatever. Then the last 10 feet of your chimney could be single wall stovepipe or even go outside the house as long as you have that initial run. So I'm sorry to be repetitive, but this is this is life and death type stuff with carbon monoxide. If you're only going up 4 feet in the house before you go outside onto a cold chimney, then if you don't do not choke it down much. You need to build speed. Okay, this final discussion is the first part is on if you wanted to go as low smoke as absolutely possible, what you could do. This is important for some people, especially in Europe, where there's almost rules and laws, and you can't have stoves anymore. In certain cities, they're illegal, and emissions and regulators and inspectors and assholes running around. So, okay, remember that the soft fire brick is an insulating fire brick versus these are regular, heavy, more like real brick fire bricks, sand and silica. The soft fire bricks they're only sold online as far as I know. They're not at the regular brick place where I go or cinder block place. They're lighter, they're easy to cut. They're not as durable, they can break easily, but they're reflective and they're good for an extra 1,000 degrees. So if I was really worried about no smoke, my three layers of this I would do in soft fire brick, which reflects the heat right back at each other. It didn't come out right, but you know what I'm saying. And you create that box before your nozzle would be a superheated zone if you use soft fire brick. Of course, you can't put a ton of weight on top of soft fire brick. Whatever, that's for you to investigate. These are regular fire brick that absorb heat. The other thing would be I would play it safe, and I'd use a 4-inch pipe. I wouldn't use just 3.5 inches goes down to 3.25. Bartender's cocktail shaker. I'd use you got to err on the side of letting gases move more quickly for safety. I'd use a 4-inch pipe. I would put castable refractory around it for going up 10 inches before the next 2 or 3 or 4 feet would be insulated pipe, which then you could go to regular pipe or single wall pipe. So you would have 2 zones of superheated, super temperatures, superheated zones. If you use the soft fire brick and then you use the 10 inches of the 4-inch pipe surrounded by, as insulation, the castable refractory. Use the castable refractory in case that metal over years and years gets eaten away. Guess there's a third thing you could do. You could put in some sort of rocket stove port, at the back. If you wanted to make your stove a little bit longer, you could put in. But I would not, in this case, since you're already squeezing it down so much, the rocket stove port usually doesn't let the gases escape all the way to the top. I would run the port all the way to the top, and I wouldn't make it too thin. Just a little bit of a rocket stove squeeze down port to initial funnel for turbulence into this zone, and then this zone would be soft fire brick for 3 levels. It would get to 1,000 degrees, and then your 10 inches of 4 inches by 10 inches of 4-inch castable refractory insulated. You'd have basically three areas of superheated. It would eat up all the smoke all day long, in my opinion. I don't even think you need if you're going to do the rocket stove port, you'd need a longer firebox, and again, run that port all the way to the top, and then this would be the initial stage of your. You'd have this sort of chimney on the all the way. This chimney starts at the top of my stove. If you were doing the rocket stove port, what you're looking at here would need to go all the way to the bottom. And you could put your little angle cuts in the sides and all. And Matt, should we do? What about the secondary air? The rocket stove people are in love with the secondary air. The most applications of secondary air, people don't know what they're doing. Okay, they don't. It's not done right. They think it's 50%. It might add a little bit here and there, and you got to be. It's not needed. It's not needed in most stoves. In this stove, it's not needed. If you put secondary air and do it wrong, you're just injecting air conditioning. You're injecting more smoke situation into the stove. So I guess last thing, if anybody's like, for anybody that wants to build this, I would, you get the best of both worlds, of course, if you put in you make it a little bit longer, and instead of using fire brick on top, get a piece of soapstone. The heat, it takes an hour and a half for all these fire bricks to truly start radiating out all their heat. So if you had a piece of granite or soapstone as your ceiling, going just about 3 feet long, and it could stick out over the sides even by 4 inches on each side. You gotta really pack it in with that imperial stove mortar. I mean, you gotta make sure no gases seep out. You gotta be very careful. Use, I don't know how you would do it. Gaskets, whatever you want to use. This thing would be so sealed up because it's 2 layers of fire brick as the ceiling. You'd use refractory mortar for fire brick, put on very, very thin, with the fire brick dunked in water for at least 5 seconds before applying the very thin layer of refractory mortar in very, very small joints for fire brick and refractory mortar. If you weren't using, this is 2 layers of fire brick for the top of the firebox. If you put that 3-foot piece of soapstone that sticks out over the edge by 4 inches, it's going to get hot immediately. It's going to start acting like an ironwood stove. You're going to get immediate heat out of it after just 10 minutes. It'll get piping hot, where you have to wait for these sort of brick stoves. And it still never gets that hot, but I don't, you could get excess pieces from the kitchen counter stores. And I know soapstone is that is what you want to use. But and I'm not sure, is the kitchen countertop soapstone the same as the soapstone used in stoves or the Tulakivi masonry heaters? I think so. I don't know. So soapstone holds up to direct flame, but from the kitchen counter, places, could you, what would a piece of, I've got to get a couple pieces of granite and test it, see how long it would take to heat up. I've got to do all that. But a big piece of granite, like a kitchen countertop throwaway piece, over the ceiling, the ceiling of the firebox, would that heat up? And again, the reason you try to create a hybrid, these all brick stoves take forever to start radiating out their heat. And if you create a hybrid where you have like a big piece of soapstone or a big piece of iron as the ceiling, then it gets hot. Like if it was iron, it starts getting hot in like 20 seconds. You start getting heat immediately, and you get the best of both worlds, because these fire bricks will absorb heat, start radiating it out in about an hour and a half, and then if you can, there's a lot of fire bricks here. It'll keep radiating out a smaller stove like this for 3 or 4 hours after the fire goes out. So an iron stove, goes cold very, very quickly. All right, guys, I guess that's everything. Thanks for being here.